I'm going to look at a stoichiometry problem that involves both mole ratio and molar mass. And so if you notice, what I've done is up at the top of the page, I have the three conversion factors that we've covered so far. You have molar mass, which is what always helps you go from grams to moles or moles to grams. Whenever you're dealing with molar mass, it's always 1 mole. And your grams comes from taking either the individual element from the periodic table or adding up all the elements needed from the periodic table. Mole ratio is when you're going to use the coefficients from your balanced equation to help you look at the relationship between reactants to reactants, reactants to products, products to reactants, or just products. And those coefficients come straight from the balanced equation. The last conversion factor is just a reminder that Avogadro's number, which is 6.022 times 10 to the 23rd, could be used with units of atoms or molecules, and that will always be equal to 1 mole. So what I went ahead and did is I took my balanced equation and I labeled the equation with the data from the question. And then I went ahead and I calculated the molar masses needed for the two specific molecules that they were discussing. So remember, when you're calculating your molar mass, so for example, sodium hydroxide, NaOH, it was just 1 sodium, 1 oxygen, 1 hydrogen. So ultimately, my molar mass is equal to just adding up each one of those individually for the total. But when I look at sodium sulfate now, I needed to take into account that I needed 2 sodiums, 1 sulfur, and 4 oxygens. And adding those up, looking at my decimal places, because that's the last operation, my molar mass equals a representation of all the atoms that make up that molecule. So comparing 2 sodiums needed with 1 sulfur and 4 oxygens, that's different than just adding up 1 sodium, 1 oxygen, and 1 hydrogen for sodium hydroxide. Again, molar mass is always grams per mole. So that means whatever number of grams per 1 mole. So now going to my balanced equation. My balanced equation has a reaction between sodium hydroxide and hydrogen sulfate. And I'm going to produce water and, I said a different compound. I'm going to have here sodium hydroxide with sulfuric acid, and I'm going to produce water, and I'm going to make sodium sulfate. So I'm starting with 200.0 grams of sodium hydroxide. So what I went ahead and did is I labeled that right here. I'm starting with 200.0 grams of sodium hydroxide. I have more than enough sulfuric acid. So this sulfuric acid right here, I have an excess amount, which means however much I need, I have plus more. So that just means I can ignore it. It's not an issue. I'm trying to figure out how many grams of sodium sulfate am I going to produce. Notice I'm not really focused on the water. That was never mentioned at any point in time. So the only things that I'm concerned about here are the ones that I've left remaining highlighted. My sodium hydroxide that I specifically have 200.0 grams of, and I'm trying to figure out how many grams of sodium sulfate am I going to produce. And so I'm going to start with my data, which in this particular question is 200.0 grams of sodium hydroxide. And I want to ultimately end with grams of sodium sulfate. That's my big picture. However, for right now, I need to get out of grams of sodium hydroxide. And so what I'm going to do is I'm going to go from grams of sodium hydroxide into moles of sodium hydroxide. The reason is I'm dealing with a balanced equation. and I'm trying to move around in my balanced equation. So mole ratio is going to be the only conversion factor that allows me to move around in a balanced equation. Because it's looking at the relationship between reactants to reactants, or reactants to products, or products to products. So to get out of grams of sodium hydroxide, I know for sure I need grams of sodium hydroxide in my denominator, and I want to get to moles, so my conversion factor here that I'm going to use is going to be molar mass. So that's going to be moles of sodium hydroxide. I already know that anytime I'm dealing with molar mass, moles is always equal to 1. I went ahead and I calculated my molar masses. So sodium hydroxide, I know that that's going to equal 39.997. And now you can clearly see that grams of sodium hydroxide cancels out, and you're now left with moles of sodium hydroxide. So right now, you're right here, and you're trying to go from here to this product. So you're trying to compare the relationship between this reactant to this product. Your best conversion factor, and the only one that's going to work, is mole ratio. So you're going to look at the relationship between sodium hydroxide and sodium sulfate. So I know that I want moles of sodium hydroxide to cancel, so I'm going to put that in the denominator, and I'm going to look at the relationship between sodium hydroxide and sodium sulfate. So now going back to my balanced equation, next to NOH it says 2, so I'm going to put a 2 down next to that in the denominator. Next to Na2SO4, there's nothing, so that means a 1. That's my coefficient. I can now go back and double check my units. Moles of sodium hydroxide cancel. And I'm now left with moles of sodium sulfate. So now I want to get out of moles and into grams. The only conversion factor that allows me to get out of moles and into grams, or grams into moles, is molar mass. So I'm going to go ahead and set up that conversion factor. I know that I want moles of sodium sulfate in the denominator so that they cancel each other out. Anytime I'm dealing with molar mass, my mole is always 1. I just go back up here to what I calculated before, which was 140.042 grams of Na2SO4. And now if I check my units, I have moles of sodium sulfate, cancel out with moles of sodium sulfate, and I'm left with grams of sodium sulfate. So when you go to your calculator, what you're going to do now is, in your calculator, you want to make sure that you take the time to divide or to multiply and skip anywhere there's a 1. So in your calculator, you're going to say 200 divided by 39.997 divided by 2 times 140.042. And whatever your calculation answer is, your ultimate last and final answer is going to have some sort of a number value, and you need it to be in correct sig figs. You need a unit, and you need a name. So we already know that for this particular question, the unit is going to be grams, and the name is going to be Na2SO4. Your sig fig value, you want to make sure that you go back and remember that you need 4 sig figs. So this part right here will be your complete and final answer.